The supply chain is a complex network of facilities dispersed over a large geography and in many cases spanning locations all over the world. It includes raw material suppliers, manufacturers, warehouses, distribution centers, and customers. These different facilities in the supply chain frequently have different conflicting objectives. For example, suppliers typically want manufacturers located in various geographies to commit to buying large volumes of their products over a period of time with flexible delivery dates. Unfortunately, while most manufacturers would like to implement long production runs, they must be nimble and flexible enough to adapt to changing consumer preferences and customer demands. Hence, the objectives of manufacturers can sometimes be in direct conflict with that of suppliers. Similarly, the objectives of manufacturers to implement large production batches can conflict with that of warehouses and distribution centers that want to minimize inventory. Typically, trying to reduce inventory can adversely affect transportation costs. Given the distributed locations of different facilities, it becomes quite complex to design an effective supply chain that reconciles all these competing and sometimes conflicting objectives. Because a supply chain integrates suppliers, manufacturers, warehouses, distribution centers, and stores as part of a network, network planning is essential. This is facilitated using a GIS. GIS-based network planning is the process by which a firm structures, optimizes, and manages its supply chain to do the following: find the right balance among inventory, transportation, and manufacturing costs, match supply and demand under uncertainty by positioning and managing inventory effectively, and use resources effectively in uncertain dynamic environments. Supply chain network planning involves three processes: network design, which is to decide the number, optimal locations, and optimal sizes of plants, warehouses, and distribution centers; inventory positioning and management, which is to identify stocking points, optimal stocking levels, and facilities to stock; and resource allocation, which is to determine when and how much to produce, procure, or purchase, and when and where to store inventory. Consequently, managing a supply chain involves making site location decisions, a natively spatial problem that has strategic, tactical, and operational implications. Alongside site location are inventory management and resource allocation issues. All three have strong spatial connections to business operations.